Chapter 4, we did the review and preview, which we focused on a couple things. We focused on sign analysis here, and that's going to be important right away in this first section of Chapter 4. And we also talked about interval notation. So that was the review and preview to Chapter 4. If you missed that, you might want to watch that video. But 4.1 here is increasing and decreasing functions. So if I draw a few functions for you, like this. First of all, anybody have a guess what this function is? Y equals, anyone remember from last pre-calculus 30 or, sorry? Yes, x cubed, good, that would be a good guess. This general shape right here is y equals x cubed. Now we don't know exactly what it is, but that's a good guess. All right, and what about this one here? Let's say 1, 2, 3. So what would this one be is your guess here? It looks like the shape of a parabola, so it's a quadratic, yeah, that has an x squared in it, yeah. Sorry? Negative x squared? No, it's opening upwards, so it is a positive x squared, yeah. But it's come down from 0, 0, 1, 2, 3 units, roughly. Yeah, so that would be a good guess, x squared minus 3. We're not sure of the width of the opening. That would be a good guess for that. Very good. Okay, and let's do one more here. This would be a straight line here through 1 and 1. So what would this, y equals x. Okay, it's going down from left to right, so it would be a negative x, yeah. And the slope, 1, 1, yeah, so slope is negative 1, so you down 1 over 1, so that's where you get a negative 1. And then, yeah, it intercepts the y-axis at plus 1. Okay, so that would be a good build for that function, okay? Good, so that's a little bit of a review, too, of identifying functions and stuff. But when we talk about increasing and decreasing functions, what we're talking about is from left to right, okay, so from negative infinity to positive infinity, right? What is happening to the graph? Sometimes it increases for part of the domain and decreases for another part. This one here, if you take a look at the far left, or negative infinity, going towards the right, you see that the y values are increasing the whole time when we go from left to right. You see that? So from left to right, the numbers, the y values, the numbers are getting larger the whole time. So this is increasing on the entire domain. So negative infinity to positive infinity. The second function, the parabola here, okay, if we go from, look at the far left, okay, negative infinity, and the far right, positive infinity, we see that the graph is from left to right coming down, right? So the y values are getting smaller as we move from left to right, up until a certain point. Then they start getting larger after that. So you could probably see that just literally as you look at it from left to right, if the line or the graph, the part of the graph, if it's kind of coming down left to right, that is decreasing, and if it's going up, it's increasing. Okay? So this one is decreasing on the interval of negative infinity to 0. Open bracket, closed bracket, doesn't matter. At that point, we have a special point there. That's so we'll just leave it open bracket. And then, of course, it's increasing. It's increasing after 0. So 0, positive. Does that make sense? And this line here, because it's a linear, it's negative slope, it is decreasing over the entire domain. And no, you do not have to put positive infinity. You can just leave it blank. So I did down here, but you don't have to right there. Okay? Okay, so you guys have any questions about that, about identifying, where graphs are increasing or decreasing as far as these three goes? Okay, if we look further at this, let's do another graph that's, really strange. Like this, let's say. And here we can see that we have, some increasing portions, right? This is increasing, the green, up into about this point. Then it goes down to about this point, right? Then it seems to be increasing again here. Okay, and literally increasing is like going uphill, right? Decreasing is going downhill. So there's increasing over here as well. So the green is increasing. See that? And that is, again, the function values. So f of x1, right here, this is x1, and this is x2, right? F of x2. Sorry, those y values here, okay? These ones here, f of x1 is always, it's less than f of x2. And for each successive x value, this one is smaller than this one, which is smaller than this one, which is smaller than this one, so on. See? They keep getting bigger, right? So this is happening, that's increasing. And of course the opposite is true for these other ones. This is decreasing and decreasing. So if we consider a similar graph and just quickly identify our points where the increasing and decreasing changes, what I want to show you is that on all of the parts of the graph that are increasing, and what am I drawing here right now? Yeah, tangent lines, okay. What do you notice about the tangent lines themselves on every point on the interval of the graph where the graph itself is increasing? What do you notice about the tangent lines here? Okay, so, sorry, what did you say? They're increasing. Okay. Okay. They are increasing is not necessarily correct. Now, I'm glad you said that, actually, because later in the course, as we move through this, you are going to find that slopes are increasing and slopes are decreasing. That means something different. But, if we look at this interval right here, I would have a slope, let's say if we quantify this, that would be like, m equals 3, then we have m equals 2, then we have m equals 1. So those are actually decreasing. But what you said second, and I heard somebody else say it, is absolutely correct. What you should notice is that all of these slopes are positive. Okay? So on increasing intervals, the slopes of the tangents are positive. It's tricky to see in my diagram here because they're all running into each other. But they're all positive. From left to right, they're going uphill, right? Now you can probably see that on the decreasing sections, oh, that's a bad line. On the decreasing sections of the graph, well, it's tough for me to draw tangents this way. Okay, that's all I'll draw. But they are all negative, right? So let's jot that down. On decreasing intervals, the slopes of the tangents are all negative. So if we're given a graph, we can clearly see that if we draw tangent lines, where the section where they're all negative, that's a decreasing section. And where they flip to positive, that's an increasing section, right? But if you aren't given the graph, and let's say you're told that f prime of x is positive on the interval -1 to 3, and f prime of x is negative on the interval 3, to 7. Okay. Let's say we're given that. We aren't given a graph. If you know that all of the slopes of the tangent lines on this interval are positive, so that means if we were to draw a quick number line, right, 1, 3, and actually that should be spread out evenly, and 7. If this was the case, you know that all the tangents are positive here, right? So we could, not necessarily going to draw this, but you know that in between there they're all positive. Now how they're changing and what the values are, you don't know. But you know that after this point, after 3, they're all negative, right, to 7. You could guess that the graph might be something, like this. It could be a part of a parabola, right? It could be something like that. So you could make a guess as to what the graph might look like, knowing this information. All right? Or if you're given something like this, f prime of x is defined as x plus 3 times x minus 2 times 2x plus 7. If you're given this, and you're asked to state the intervals of increase and decrease of the function f of x, you could actually do that by figuring out where the derivative, where is it negative and positive, right? And how would we do that? What's the skill we just previewed or just reviewed? Sign analysis, okay? So let's just pause for a second and frame this question, and then we'll figure it out. So if this is the question we're going to look at here, we could figure this out using sign analysis. Sign analysis. Because we want to know where this is positive and where it's negative. Now, in this question I've given you the derivative. You may have to find the derivative first, right? You may have to find the derivative and factor it in order to do this for some questions. But this question, kind of an entry-level question, here's the derivative. Let's try and find intervals of increase and decrease. So, sign analysis says that we place the factors, right, kind of on the vertical sort of axis here. We have a little bit of a number line going down here. And underneath that, we would have our function, or in this case, our derivative. And we'll put the sign of the derivative kind of down underneath that. So you analyze sort of the sign of the function, or in this case, the derivative, for each interval based on the factors. So from yesterday, let's find out, place in our number line, the value for x that yields a 0 here. So that's going to be -3. It's going to be a 0. If you have a value that's greater than -3, like 0, you're going to get a positive value. So it's positive on one side, negative on the left side. So for this particular factor, this is how the x values pan out. Any x value that's less than -3 is going to yield you a negative value for this factor. Greater than -3 is going to yield you a positive value for this factor. We do the same with the other two factors. So let's just put +2 over here. That's going to make this factor 0. So negative ahead of that and positive after. What about this one here? 2x plus 7. Where is the 0 value? There. That might not be as easy to see. Where is that equal to 0? Well, you simply solve it, don't you? Yeah, sorry. X is, I did too many steps at once. So x is 0 at -7/2. Does that make sense? All right. So what is negative 7 over 2? What is that? That's negative 3.5. This doesn't have to be the scale because you need to kind of see what the signs are in between, right? So actually we should write that as a fraction, not a decimal. Negative 7 over 2. All right. Okay, so those are the important points. So let's just fill this in now. These are the important points right here, important values, which we'll give a name to here soon. But these are going to tell us where the function, because these are all multiplied, right? It's this number times this number times this number. So right in this spot right here, the derivative is going to be 0. Okay, the derivative 0. Also in this spot right here, it's going to be 0, right? Because one of the factors is 0. And here, you have another value of 0. Everyone see that? All right, negative times a negative times a negative is negative. In between here, it'll tough to see because I didn't probably can't see any signs there. But we got negative here, negative, and a positive. So that's going to be positive. This is going to be negative, and over here, positive. So now we can see the intervals clearly. We can see the signs of the derivative. And remember, if the derivative is negative, right? Negative, that means we have what? The point of tangencies line up and they're decreasing. Okay, so negative slopes mean we have a decreasing interval. Positive slopes, mean we have some kind of increasing. And then again, negative, positive. So it looks like something like this, and I'm not saying this is what it looks like, but it could be something like this where we have a graph that looks like this. So straight from the sign analysis, you could say the function, now remember this is the function, is increasing on, where's our intervals? Well, there to there, and here, I guess on, right? So on this interval and this interval, which is between negative 7 over 2 and negative 3. That interval right there. And you can just use open brackets for this sort of question. And then from 2 on, everything greater than 2. So do you remember this little set notation with the U means, which one's that one? It means as well as it's the or this. So it's the union or. So this one and the other one would be 2 to infinity because it's everything greater than 2. F of x is decreasing on the intervals, and if we just look at that where we have negative slopes, so that's negative infinity all the way up to negative 7 over 2, and also in union with this interval right here where it's decreasing. So that's from negative 3 to positive 2. And this would be your answer. That's where the function is increasing and decreasing. Okay, so try this example on your own. Find the intervals of increase and decrease, if there are any, for this function. And I'm giving you the function here and not the derivative. So intervals of increase and decrease. And I want you to use sign analysis. And so use this method that we've been looking at. You may be able to figure out this another way a little bit quicker, but I want you to practice your sign analysis. You do, yep. You have to find the derivative first. Then you have to factor the derivative. if you can. Do sign analysis. And then state your intervals. Okay, so go ahead and take a minute to do that. So your derivative 1 minus 2x, where is 1 minus 2x? Where is that equal to 0, right? So do your little 1 equals 2x, x equals 1/2. So at x equals 1/2, you can... Alright, so we have this special number right here that yields 0. Right? Now you got to be careful with this. Remember the x term is negative, right? So you should do some test values there, like 0 is over here, right? 0. So what happens if you plug 0 in? Right? You got 1 minus 0 is positive. So you got to be careful. What's going on? Okay, so it's positive on this side. See? No, remember 1 minus 2x, where does that equal 0? So it's positive. So it's negative on the other side if you took something like 10 over here, right? What's 1 minus 2 times 10? Well, it's 1 minus 20, which is negative 19. So that's going to be a negative there. Now, that's a random number I picked right here. Just a random test. But any value that's greater than 1/2 will yield a negative answer for this. So, in that case, right, let's just make some room for ourselves here. In that case now, there's only one factor, so the derivative, right, is positive here, it's 0 here, and it's negative over here. So it's increasing on what? What's the interval? Not infinity, nope. Negative infinity, yeah, to 1/2, yeah. And it is decreasing on 1/2 to infinity. Very good. Okay. So here's your steps. Find the derivative, make sure it's factored, do sign analysis, and state your intervals done. Alright, so try this example. Derivative. Factor. All the steps. Alright. Now you may have some issues when you get to the factoring of the derivative. I'm not sure, but give it a try. Okay, here's your derivative, factor it out. Now that's really easy, see? Quadratic. You don't even need to do synthetic division. Also decreasing on negative infinity all the way up to negative 1 in union with 0 to 4. See that? Yes. So that's your answer in black there, and that's kind of how you do that. So you can look over that question again. What I'm going to do is I'm going to get the graphing calculator up here, and what we'll do is we'll graph the original function, which is right there. We'll graph the original function, and we'll just see if these intervals are correct. Okay, so once we have this graphed on the graphing calculator here, you can see it there. Here's the picture of it. Now, I had to adjust the window quite a bit. So it's coming down till about this point right here, which coincides with negative 1. So we do have the decrease up until negative 1 here. Just get that answer back. And then we have, it's tough to tell, really tough to tell, but we have slight increase to 0. Okay? And then after 0, it decreases again. So if I were to just kind of blow this area up right here, okay, and I think I saw, like it would be kind of like this, negative 1 up to 0, and then back down, and then at 4 would come back up. Okay? Now I think I saw some of you, or one of you maybe do this. Okay, you have to be real careful with this because here is your high, it's still increasing here when it's really not on the graph. So this 0 part, wherever it is, has to be the maximum kind of point in this area. Okay? Where you come up to, it doesn't matter. We don't know y values yet. We could go further, and next chapter we will. In curve sketching, we're going to use this to sketch a really complicated graph. But right now, we don't know exact values, so we don't know how low it goes. It's here or here or here. We don't know that. We don't know how high it goes, but we know it just starts to decrease after 0, and we don't know how low, and so on. So again, here is the graph. It matches up, right? Decrease here, decrease here, and increase here, and increase from 4 on. So the graph matches up with our work. Congratulations.